Sir, you on mute.
All right, thank you. So I was saying that today will be complete. Today will complete tangent and normal topic. Okay. So based on that, in level one there are 85 questions. Okay, they are as homework for you, and they're not very lengthy questions. Okay, can be solved in like roughly 2 to 3 hours. Will be discussed on the next turn. Three topics we have already studied and discussed. Okay, so try to do these questions by next turn. Now regarding the topic, tangent and normal is going on, and we are studying about the angle between the two intersecting curves. Okay, it is defined as the angle between the tangents at the point of intersection. Also we studied about orthogonal curves also. If at each point of intersection the angle between tangents is 90 degree, we say that curves are orthogonal. So we took few questions as examples. We'll be taking one more and then we'll proceed to the next topic. Find the angle between the curves. Find the angle between the curves y square equals 4x and y equals e to the power minus x by 2. So in this question, what we generally do, we generally start by finding the point of intersection of the two curves. Okay, and you won't be able to do it here because one of them is exponential function, other one is algebraic function. You can't actually solve them. Rarely it happens that you will get the point of intersection by solving. In fact, not by solving, by observing, which may not be happening here. So in such cases where we are not able to find the point of intersection, still angle is asked, what to do? That is why I'm taking this question. We will suppose that the point of intersection be x1, y1. Let x1, y1 be the point or points of intersection. Why I'm saying that point or points? Because if there is only one pair x and x1 of, if there is only one pair of x1 and y1, we will read it as point. But if we get more values of x and y, we will read it as points of intersection. That will depend on how many values of x and y are there. But we don't know because we are not able to find them. So let it be x1, y1. So what will happen? Since it represents point of intersection, it will satisfy the equation of both the curves. So after that we have these two equations. Now we need to find dy by dx at these two. So 2y dy by dx is 4. Dy by dx is 4 upon 2y. We have to find dy by dx at x1 y1, so it will become 2y by 1. Similarly, we will differentiate this one. Dy by dx is e to the power minus x by 2 into minus half. Minus x by 2 into minus half. So dy by dx for this curve is minus of e to the power minus x1 by 2 upon 2. So now you have basically slopes of both the tangents at the two curves m1 and m2, and you have to find the point of intersection. Sorry, angle between the tangent. Now see one thing, the formula is tan theta upon m1 minus m2 upon 1 plus m1 m2. Since you have to find the angle between the tangents, so one thing is sure, that you have to definitely find the value of m1 into m2, right? So first of all, rather than finding m1 minus m2 or putting the value, you find this particular value separately, m1 into m2. We will solve it and then let us see what happens. 2 by y1 into minus e minus x1 by 2 upon 2. This gets cancelled, and with the help of this part, the second equation, I got the answer. Why? Because in place of y1 I can write e to the power minus x1 by 2. This comes out to be minus 1. Question is over. Whatever or how many points of intersection are these doesn't matter. At all these points x1, y1, I am getting the slope of product of slopes as minus 1. That means m1, that means two lines are perpendicular. Tangents are perpendicular or curves are orthogonal. So whenever you have to find the angle between the tangents, you always find m1, m2 first. Because if it comes out to minus 1, the answer will be orthogonal. And if it is not coming minus 1, still you need to put it here in the formula. So that is why. And here what is the best part? Even though you don't know what is the exact value of the point of intersection or how many points of intersection are there, still you are able to get that they are orthogonal. So remember, whenever you are not able to find the point of intersection, just assume it something, put it in the two curves, find dy by dx at that point of both the curves, and always find the slope of product of slope first, and then you can proceed. If it is not minus 1, it is something else, you put it here, then find m1 minus m2. But obviously these x1, y1, they can be eliminated by the help of these two equations that points satisfy their curves. So this was the concept of this question. The question itself is there in the notes, so no, not to write anything. Now the next concept is shortest distance between the curves. Shortest distance between two non-intersecting curves. Because if the curves are intersecting, obviously distance between them is 0. Shortest distance between two non-intersecting curves. So because if they are intersecting, distance will be 0. They will have point of intersection. So what is the meaning of distance there? So it is defined as the distance between their parallel tangents. Parallel tangents. At the same time we write or along their common normal. Or along their common normal. To understand this thing, let us take example of two circles. Suppose you have two non-intersecting circles like this, and you have to find the shortest distance between them. Okay, you have to find the shortest distance between them. So you have two options. You can say that it will be along their common normal. Normal, as you know what is normal. So if normal is there, there must be tangent. If normal is there, there must be tangent, right? So we have two options. Either we can say that the shortest distance, which is actually AB here, shortest distance. Okay, there was this formula of shortest distance in vector 3D also, remember? So here we don't have any formula. There is this concept which is written, which is actually the definition itself. So if like there are two circles, there can be any two curves, a parabola, circle, graph of sin x and a circle, a parabola and ellipse. They can be any two curves that you have studied. Okay, if they are not intersecting, they can ask you to find the shortest distance between them. So what you will do? What is the definition? It is defined as the distance between their parallel tangents. You can see that L1 and L2, their tangents to the two circles, they are parallel to each other. At the same time, there is this common normal, means normal to both the curves. And tangent is perpendicular to normal, so that's why I made 90 degree. So this distance AB, this will be calculated by this definition that it is the distance between parallel tangents or along their common normal. Since normal and tangent, these things are coming, therefore this article is included here. As you may have to find dy by dx and all. No formula, because there can be any two curves, so how can anyone define a formula? So find the shortest distance. Make sure that the curves are non-intersecting, okay? Otherwise distance will be 0. Find the shortest distance between the curves. Y equals x minus 2 and y equals x square plus 3x plus 2. Okay, so what to do? See, first one is a straight line, second one is parabola. This is your parabola. Y equals x square plus 3x plus 2. And the line is this. If you want to show that they do not intersect, just do one simple thing. Sorry, this is 0 comma minus 2. Do one simple thing, solve both of them. How you will solve? Solve both. Because you may think that I have drawn the diagram such that they do not intersect. Maybe they may be intersecting. So for that, I equate y of both. Why we equate y of both? When we are equating y of both, that means we are equating their y coordinate. So that means we are sharing some y, same y. So let us do one thing. Let us try to find whether they have same x also. So for same y, if they have same x, that means they must be having a common point. But it will not happen here. Why? D is negative. No real roots. So that means no intersection. Now we can proceed. So now we have to find. Now we have to find. Yes. So now we have to find distance between these two. One of them is a straight line, other one is a parabola. So what to do? What is the definition? Either you find the distance between their parallel tangents or you find a distance along their common normal. Now listen, straight line. If you take any point on it and draw a tangent to it, it will be the line itself. A line is a tangent to itself. Why? You take any point on this curve, you draw the tangent. Where you will draw? On the line itself. So this is actually like acting as a tangent to itself. So let us draw a tangent to the parabola. This one. That means the distance between these two red and black lines will be the shortest distance. Okay. So let us draw the normal now. Let us draw the normal. So this will be the common normal and this distance AB will be your shortest distance. Okay. Now we have to find AB. So what we will do? Let us consider this point as x1, y1, which is on the parabola and also on the tangent. So what is the use of application of derivatives? We differentiate. So dy by dx is 2x plus 3. Let us find the slope at x1, y1, which is the point of contact. This comes out to be 2x1 plus 3. And we equate this to 1. We equate this to 1. Why? Because the tangent to the parabola is actually parallel to the line. This is the concept. Distance between parallel tangents or common normal. So in this way, we have calculated the x coordinate of point A. Now we have to find y1. Since x1, y1 lies on the curve, since y1 will be x1 square plus 3x1 plus 2, so you put it there. So y1 will come out to be 0. Minus 1 square is 1 minus 3 plus 2. So you have this point of contact as minus 1 comma 0. Okay. So now you have this point. Now you have that this point as minus 1 comma 0, this x1 y1, and you have to find AB. You have to find AB. Now can you look at the diagram, okay, and tell me how to find AB, because now you will get the answer. You have this A point. You can see the diagram. You have to find distance AB, which is the shortest distance here in the question. How you can do it? How can you find this distance? Yes, any one of you. With the knowledge of point A, coordinates of point A, how you can find the distance AB? Yes, anyone? Any one of you? See, basically, you have this equation of black line, which is the line given in the question itself, and you have a point A. You can't find AB. Richa, can you tell me how to find this distance? So this is coordinate geometry. What is the problem? Point A is minus 1 comma 0. You have the equation of line. You have learned the formula for length of perpendicular distance from a point A on a line. So this equation is what is this equation? X minus y minus 2 equals 0, right? This is the equation of line, and the point is minus 1 comma 0. So AB is distance of point minus 1 comma 0 from the line x minus y minus 2 equals 0, and this will be equal to mod of, you put minus 1 and 0 in place of x and y, by under root 1 square plus minus 1 square, that is 3 by root 2 will be your answer. So 3 by root 2 units is the shortest distance between these two curves. So what is the application of derivative? Parallel tangent dy by dx. What else you could have done? Coordinate geometry. Uh, you have this equation of line y equals x minus 2. Its slope is 1. Therefore, slope of AB will be minus 1. So you have slope of AB, you have point A. You write its equation in the point slope form. Now you will have the equation of the blue line and the black line. Solve both of them, you will get B also. You have A point, you have B point, you want the distance AB, use simple distance formula. In that way also you can calculate this distance, you will get 3 by root 2 only. So this is the concept of distance, finding the shortest distance, okay? Then here there are some important curves whose parametric coordinates we should know. Some important curves whose parametric coordinates must be remembered. Just like in the parabola, there is, in case of parabola y square equals 4x, we have the parametric coordinates as 80 square 280. In case of circle, x square plus y square equals r square, the parametric coordinates are r cos theta, r sin theta. Similarly, there are some different curves which you have not studied till now, and they are not even required, but just they are required to differentiate. So it is better if we remember their parametric coordinates. So these are the values of x and y which satisfy this equation only. So that means it is a point on this curve, or in other words, we say it is the parametric equation of this curve. You put this x and y here in the first curve, you will get a2 by 3, because there will be identity cos square plus sin square, and rest it will become a to the power 2 by 3. So that's why. And similarly for y square equals x cube, we take x equals t square and y equals t cube. Then for third part, for under root x plus under root y equals root a, we will solve two questions on this. Put x equals a cos 4 theta plus, sorry, y equals a sin 4 theta. So we are going to solve questions second and third. You will come to know what is their application. And if you have this curve, so they are not standard normal curves, okay? You will be studying about them in engineering mathematics, but they come to differentiate. No? Sometimes they will say that this is the curve, find the slope of tangent at this point. Then that we can do, no need to draw the graph. Sorry, this has been repeated, just a minute. Is for x to the power n upon a to the power n plus y to the power n upon b to the power n equals 1, we put x equals a cos theta 2 by n. A is outside, cos theta to the power 2 by n, y is b sin theta to the power 2 by n. So if you will put these coordinates or these values of x and y in their respective equations of their curves, they will satisfy. Like for example here, y square equals x cube. If here in place of x you put t square, so t square cube is t to the power 6. You put y is t cube on the left hand side, t cube square. So left side is t cube square, right side is t square cube. Okay. So both are becoming same t to the power 6. So in that way, like this one, you put in place of x, you put a cos 4 theta. So it will become under root a cos square theta. This will become under root a sin square theta. You take root a common. Cos square plus sin square is 1. It will come out to be root a. So like that. Okay. So based on these, solve two questions. Find the sum of intercepts on the axis. This is very important question. Sum of intercept, you will find this in your question bank also. Intercepts on the axis, plural form of coordinates by any tangent to the curve under root x plus under root y equals 2. This is the question. So basically, we have to find the equation of its tangent. Based on that, we will find its intercepts. Okay. We will find its intercepts, x intercept, y intercept, and then we will add them. And it is supposed to come a numerical value, I think. So how to proceed? Listen, we don't know the graph of this equation. No problem. Let any point on this. So any point means I'm supposing it like x1, y1. Let any point on this curve is. So actually this is comparable to third one. Root x plus root y equals root a. On this curve means root x plus root y equals root 4. 2 is root 4. So what is the point? A cos 4 theta a sine 4 theta. So that will be 4 cos 4 theta, 4 sine 4 theta. So let me write simply like this: 4 cos 4 theta, 4 sine 4 theta in place of x and y like this. Why? These are the parametric coordinates of the point on this curve, any point on this curve. We have to find the equation of tangent because with the help of that only we will be able to find the intercepts. And what is the equation? The previous class starting y minus y1 equals slope into x minus x1. So slope, again slope is coming. So we'll have to differentiate it. So 1 by 2 root x plus 1 by 2 root y dy by dx chain rule equals 0. And x and y are these values. So we can put it later on. First let us simplify them. Minus 1 by 2 root x. Then 2 gets cancelled. So dy by dx is minus of root y upon root x. Put this value of x and y here. 4 cos 4, 4 sin 4. At this point we are calculating. So what about numerator? Minus of 2 sin square. Root is coming. Here it is 2 cos square. It will come out to be minus of tan square theta. This is the slope. And the point is this only. So what is equation? Therefore equation of tangent is y minus y1 equals slope into x minus x1. Let us simplify this little bit. So y minus sine 4 sine 4 minus x tan square minus into minus plus 4 cos square into tan square sine square upon cos square, that is 4 sine square. So this becomes x tan square theta plus y. Shift 4 sine 4 to the right hand side. Take this common. Okay, sine square by cos square. And do one thing. Now you can find it from here only. X intercept. How we find x intercept? In coordinate geometry or anywhere, if we have to find the x intercept of line, we put y equal to 0. So x intercept, for x intercept we put y as 0. So this is 4 sine 4 plus 4 sine square. Putting y equal to 0, left hand side will be x tan square. So upon tan square. Then y intercept. Y intercept of any line which is tangent here, we put x equal to 0. So what is the result? Put y x equal to 0, you will get y as 4 sine 4 plus 4 sine square. Question is find their sum. So before we find their sum, let us simplify them. So what we can do, we can change this tan square in terms of sine and cos. 4 sine 4 plus 4 sine square. When you will write tan square as sine square upon cos square, sine square will remain here, cos square will come in numerator. And then we can take sine square common and cancel. So it will be 4 sine square plus 4 into cos square. So let us add them now. So there sum 4 sine square plus 4 cos square plus 4 sine 4 plus 4 sine square. Okay. It should be a numerical value. Let us see. So what we can do, we can first multiply cos square. So 4 sine square cos square plus 4 cos square plus 4 sine 4 plus 4 sine square. First we will add second and fourth term. This will give us value 4. And let us combine these two. If we combine these two, we can take 4 sine square common. So it will be cos square plus sine square. And from here I am getting 4 only. Is there any mistake? Because answer has to be a numerical value. Just a minute. Let me check if any calculation mistake is there. Slope is correct. This side there is some mistake in the question. Y minus y1. Y1 is 4 sine 4. Okay. See, there is problem here. I just wrote it in a wrong way. X1 is 4 cos 4. It is not 4 cos square. It is 4 cos 4. The problem is here. 4 cos 4. I wrote it for 4 cos square theta, right? So what will happen if I will multiply this? So with sin square, cos square will also be remaining. 4 sin square, cos square will come. It will be 4 cos square. Then it will become little bit easy. Why? There will be some changes. Wait. There will be lesser calculation, not this much, because it was 4 cos 4 and not 4 cos square. Now what will happen? I will even simplify that equation further, because in the RHS I can take 4 sin square common and that will only remain there. Wait a minute. So this part is x tan square theta plus y, and in the right hand side only 4 sin square will remain. Why? Because sin square plus cos square is 1. Now we take x intercept, we put y0. See, very simple expression will come 4 sin square upon tan square. Put y0 and then shift tan square on the right hand side, and that will be ultimately 4 cos square theta. Yes. Then for y intercept we put x0. We put x equal to 0 in this equation. So what about y? Y is 4 sin square. Simple answer 4. Their sum 4 cos square theta plus 4 sin square theta. This will come out to be 4. That is the answer. So I hope you might have understood that how to use the parametric coordinates. Okay, in place of x1 y1 we generally take this parametric coordinate. Okay, let us take another question on parametric coordinate only. If the tangent to the curve, this time it is y square equals x cube, tangent to the curve at a point P intersects it again. Tangent is only intersecting the curve again at point Q. Then find value of slope of OP upon slope of OQ, where O is origin. Now see, we don't know how to draw this graph. Okay. But we can just try to visualize the situation here. There is some curve. Okay. And there is a tangent to it at some point, which is intersecting this curve only, but at some other point. See this. This is not the actual curve. This is just trying to, we are just trying to visualize the situation that how can a line be a tangent to a curve at a point while intersect it again at some other point. Okay, it can be like this. So tangent at point P intersects the curve again at Q. O is origin, O is 0 comma 0. So the one thing that we have to use here is the parametric coordinates. So y square equals x cube. Let us come back again to the parametric coordinates. For y square equals x cube, we have to use this form, that x is t square and y is t cube. X t square y t cube But now there are 2 points P and Q on the same curve. So because of 2 points, we will use the notation T1 square comma T1 cube. Because I have to assume coordinates of Q also. So what about it? It is second point. Let us say it is represented by T2. So T2 square comma T2 cube. This will be the second point Q. Now let us see what is the question. Question is slope of OP upon slope of OQ. We have coordinates of O, we have coordinates of P. Slope of OP can be calculated here also. Y1 minus Y2 upon X1 minus X2. It will come out to be T1. It will come out to be T1. Similarly, slope of OQ will be T2 cube minus 0 upon T2 square minus 0. It will be T2. So basically question is what is the value of T1 by T2? This is not the answer. This is the question. So basically you have to find the numerical value of T1 by T2. So how application of derivative will be used? You will find dy by dx. Y square equals x cube. Therefore 2y dy by dx equals 3x square. So dy by dx is 3x square by 2y. We find dy by dx at point P. That means we put the coordinates of the point P in this. In place of x, I will write t1 square. In place of y, I will take t1 cube. This comes out to be 3 by 2 t1. So I have calculated the slope of tangent at P, which we can see from the diagram is actually PQ only, because tangent is meeting the curve again at Q. So what I will do, as we have done in previous classes also, once I calculate slope using differentiation, and second time I will calculate slope using 2 point form, y2 minus y1 upon x2 minus x1, and I will equate both of them. So now I can get this value t1 by t2. How? Simplification. In the numerator and denominator, t1 minus t2 is common. We need to cancel it. So what will be left? A minus b is cancelled. A square plus b square plus ab. In the division, it will be t1 plus t2. Cross multiply. 3t1 square plus 3t1 t2. Right hand side 2t1 square 2t2 square plus 2t1 t2. This comes out to be t1 square plus t1 t2 minus 2t2 square. Simplify this. Factorize it. 2t1 t2 minus t1 t2 minus 2t2 square. So t1 into t1 plus 2t2 minus t2 common t1 plus 2t2. So basically you have got the factors. From here you will get the value. One answer will be t1 equals t2. Other answer will be t1 plus 2t2 equals 0. Second answer will give t1 as minus 2t2, and you need to find t1 by t2, which is answer minus 2. The question was find t1 by t2. Okay. This was the question, slope of OP upon OQ. So minus 2 is the answer. But here I am saying that this is rejected. T1 by T1 equals T2 is rejected. Otherwise, if it was not rejected, answer will be T1 by T2 equals 1. But who can tell me why T1 equals T2 is getting rejected? Why T1 by T2 minus 2 is the answer? Why we are not accepting T1 equals T2? What is the reason? Why T1 equals T2 is not possible in this question?
So then the point P and Q will be the same.
Yes, good. Then what will happen if T2 is T1? Then Q point will also be T1 square comma T1 cube. P will become same, and the that tangent to the curve at a point P intersect again at Q. Okay. So then overall it will make no sense. This will be rejected. Minus 2 is the answer. Question has been solved in the notes as well. The purpose was to tell you the application of the parametric coordinates. Okay, so these four curves are important. Just remember them. Remember their parametric coordinates. That will be sufficient. Now, finally, in tangent and normal, we come to the last topic, which is more formula based. The last heading is length of tangent, subtangent. There are four formulae, okay? Normal and subnormal. Tangent and normal, two more terms are introduced, subtangent and subnormal. Okay, and you have to tell that what are the formula for their length. Okay, the results first. I will use the short form. LT means length of tangent. I am writing the formulas that are there in your notes also, but you may need to solve some questions here. So you can write if you want. This is your length of tangent. I will tell you what is x1, y1 here. Obviously, it is some point. Okay, y modulus length cannot be negative. Then L of ST means length of subtangent, which is y1 into dx upon dy at x1, y1. Third, length of normal, mod of y1 into root of 1 plus dy by dx whole square. And finally, fourth one, length of subnormal is y1 into dy by dx. You remember one, you will get the answer of the other one. How? If you remember length of subnormal, let's say you remember the last one. What is length of subnormal? Y1 into dy by dx at x1, y1. Then it will help you to remember length of subtangent. Why? Because in place of dy by dx, you have dx upon dy. Similarly, you remember length of normal, and because of that, you will remember length of tangent. In length of normal, we have y1 into under root of 1 plus dy by dx whole square. Tangent, you are getting dx upon dy whole square. Also, one more thing, do not get confused. Generally we think that if there is tangent involved, it should be dy by dx. But see, just the opposite is happening. Normal, in formula of normal or subnormal, we are getting dy by dx, and in formula of tangent and subtangent, we are getting dx upon dy. That is because of the proof. Okay, but do not get confused. Rest best part is everywhere there is y1 into y1 into y1 into. So I hope you will remember them very easily. But before that, let us see what is x1, y1 and why they are finding dy by dx at this point. And what are the actual meanings of length of tangent, subtangent, subnormal, everything. So suppose that you have some random curve y equals fx. Let us say a differentiable curve y equals fx. And at a point p x1 y1 of it. So now you come to know what is x1 y1. X1 y1 is actually a point on the curve itself. Okay, so nothing new. Point is x1 y1. So its coordinates are used here in all these formulae. Now at this point I'll be making a tangent to it. Okay, tangent to the curve. Tangent. Then what else? Normal. So let me draw the normal. Normal. So this angle will be 90 degree. Tangent and normal are perpendicular to each other. Now, first of all, listen carefully. This is your point P. This point is P. Okay, this blue dot. This is point P. Let us say this point is A. and this point is B. Now listen. How we measure the length of tangent? What is the length? That is mod of y1 into under root 1 plus dx by dy whole square. It is length AP. So how you will remember what is length of tangent? It is the distance from the point of contact to the point where tangent cuts x-axis for the first time, or maybe only one time only it will cut. So what is P? P is point of contact. Its distance, or the distance along the tangent from it to the point where tangent cuts x-axis. That means PA. So here in length of tangent I am writing what is this length? This is length PA. Now similarly on the similar pattern, what is normal? It is length of normal. It is the distance from the point P till the distance where the normal cuts the x-axis. So that means the length of normal is PB. I have written there also. So these I am writing bracket with reference to the diagram. Now there are two more points, subtangent and subnormal. Okay, what are these now? So first of all, what I will do, from this point P, I will draw a perpendicular. I will draw a perpendicular from a point P. I will draw a perpendicular to this x-axis. Let us say it is T. So as a result, I am getting two lengths. I am telling you what are those lengths. One length is your AT. One length is your AT. You know what is AT? AT is your subtangent. AT is your subtangent. So if anyone asks what is subtangent, so you will say it is the projection of length of tangent on x-axis. What is subtangent? It is projection of the length of tangent on x-axis. Length of tangent is PA. Its projection on x-axis is AT. That is your subtangent. So now you can tell me what is subnormal. Subnormal will be subnormal will be the projection of the length of normal on x-axis. So this yellow one, this is your subnormal. So from point P to point A, that is PA, this is your length of tangent. P to B, this is your length of normal. Projection of P on x-axis, that is AT is subtangent, and projection of normal on x-axis, that is TB, is subnormal. So these are the lengths. Now we have to find their formula. How these formulae are coming, let us see quickly. We will start by taking this angle as theta. We'll start by taking this angle as theta. There is a particular reason that I am taking this angle as theta, not any other angle. Who can tell me what it has to do with the question? Why this angle only as theta? How it will be used in finding these heights? Can anyone tell me? I could have taken PB as theta or maybe some other angle, maybe TPB as theta, but why I'm taking this only as theta? I mean, why I'm considering this particular angle, not any other angle? What is the reason? Because see, this is the angle made by the tangent with x-axis. So if you remember slope, so here you have one important point that dy by dx, which you will be finding at x1 y1, will give you slope of tangent, and which is tan theta by coordinate geometry. So this will help you to find all the lengths. Like for example, you want to find, I will not find all these four, just two of them. Let us say I want to find length of subtangent. I need to find this formula, this y1 into dx by dy. So what I will do in triangle PAT, in triangle PAT, I will find tan theta. So that is a simple right angle triangle. So in triangle PAT, tan theta will be PT upon AT. So we have to find AT. So AT will be PT by tan theta. What is PT? If you look at the diagram and if you consider the coordinates, see from O to T, O is origin, O to T length will be x1 and from T to P length will be y1. Why? Because the coordinates of PC, if you have the coordinates of P as x1, y1, what happens? How you get these coordinates? From O to this point you get x1 and then here you get y1. Same thing is happening here. If you look at this height TP, it will be y1. So y1. What about tan theta? Tan theta is dy by dx at x1, y1. Then you know that the reciprocal of dy by dx is dx upon dy. And then you write like this. This is your AT, that is length of the tangent, subtangent. But to be on a safer side, we keep a mod with this length y1 into dx upon dy. We have taken modulus. Just like in coordinate geometry, we used to say that area cannot be negative. So we used to put modulus with that expression x1 into y2 minus y3 and like that. Because see, here it looks like that y1 is positive. Because I have drawn the curve in the first quadrant, y1 is present in the first quadrant. So it may be okay here. But what about if point is in some other quadrant? Or what about dy by dx is a negative value? So length cannot be negative. That is why to make sure that length come out to be positive, we put a modulus sign with every formula. Okay. Because ultimately coordinates and slopes can be negative, but length cannot be negative. So this is your subtangent. Now similarly, if you have to find, let's say you have to find length of normal. Suppose you have to find PB. If you have to find PB, come back to the diagram. This angle has been considered theta. This is 90. So this angle, this one by angle sum property will be 90 minus theta. Because triangle APB is a right angle triangle. One angle is 90, one is theta, other should be 90 minus theta. And let us apply trigonometry once again in triangle PTB. So in triangle PTB, we need to find value of PB and we have PT. So I will go for sine. Sine of 90 minus theta will be perpendicular by hypotenuse. So it will be PT upon PB. This becomes cos theta. This is PT is y1. You have to find PB. PB becomes y1 upon cos, that is y1 sec theta. Now from trigonometry, you know that in place of sec theta, I can write under root 1 plus tan square. 1 plus tan square is sec square. Sec square root will become this. And I'm going to put modulus also finally. So question is over. Why? Because tan theta is your dy by dx. So y1 plus under root dy by dx whole square at x1 y1. And then we put a modulus sign and this will give you length of normal. PB is your normal here. So likewise, you can use trigonometry and find all the respective lengths. Okay. So this is also there in your notes. So based on these four formula, let us solve 2-3 questions and that will end this topic as well as the class. Homework I have already given you and you come for the next class, before that you complete everything. So let us solve 3-4 questions. In fact, 3 questions we'll be solving because you will find so many questions on in your question bank as well. Find length of tangent to the curve. Find length of tangent to the curve y equals x cube plus 3x square plus 4x minus 1 at x equal to 0. Question number 2. Find length of subtangent. Tell me what is the answer of the first question. Solve it quickly. So I have taken 3 questions. There are total 4 formulas. So each question is based on a different formula. Solve it and that's it. Yes, what is the answer of the first part? You need two things: point of contact and dy by dx at that point. So when x 0, y is -1. Dy by dx is 3x square plus 6x plus 4. You find dy by dx at this point. So this will come out to be 4. What is formula of length of tangent? Mod of y1 into under root 1 plus dx by dy whole square at x1 y1. So you have everything here. Y1 is -1 and dx upon dy. You are supposed to substitute value of dx by dy. So that will be reciprocal of it. So 1 by 4 whole square. So overall you will get root 17 upon 4 mod, that is your answer. Root 17 by 4 units. Length of tangent. There's nothing much about this, just the formula. Try to solve second question.
So, so for the second question, do we need a point?
Is anyone got the answer?
So for the second question, do we need a point?
Or no, sorry, I just forgot to tell you. Here you need not to have any point. You will assume some point x1, y1 and answer will be coming in terms of a. Because see, you are studying y equals fx. So whatever alphabet is there in apart from x and y, it is treated as constant. So length will be coming in terms of a. You start by assuming the point as x1, y1. Given curve is y equals e to the power x by a. Let any point on it is x1, y1. Therefore, dy by dx is e to the power x by a. Use chain rule 1 by a into. Then the slope of tangent at this point x1, y1 comes out to be e to the power x1 by a upon a. What you have to find? You have to find the length of subtangent here. Okay. Therefore, length of subtangent mod of y1 into dx by dy whole, not square, simply this value. So this comes out to be y1 into. Now if this is dy by dx, what about dx upon dy, reciprocal of it? So now you must be thinking that we are getting this answer. But one more important point. Also, point satisfies its equation, means equation of the curve. So now in place of y1, you will put this and you will get mod a as the answer. Because you don't know x1, y1, it will not be coming in the answer. You will get mod a and that will be the answer. Just leave it as mod a only because it is not given whether a is positive or not. So mod a units also you can say mod a units, that is the length. Here also root 17 by 4 units, just like that. So point is not given. You assume it, use the formula, it will be cancelled or eliminated somewhere. Use the fact point satisfies the equation. Okay. Solve the last question. In this third question also, variables are x and y. Variables are x and y, a and n are constants. So what is that constant value of a? Sorry, constant value of n for which this whole length, that is length of subnormal, comes out to be a constant. So in the same way, consider any point x1, y1. Find the length of subnormal and then you will see how it becomes constant. So given curve y equals a to the power 1 minus n x to the power n. I think this is the curve. Yes. Let any point on it. X1, y1. Differentiated dy by dx equals. First part is constant, so n into x to the power n minus 1. Let us find it at x1, y1. This is a to the power 1 minus n into x1 to the power n minus 1. Now length of subnormal is mod of y1 into dy by dx at x1, y1. So this is y1 into dy by dx is this. Also, so similar to the previous question, point will satisfy its equation. So in place of y1 you will put this value here, a to the 1 minus n into x1 to the power n. Then you write these values. So here it will become n into a to the power 2 minus 2n. I am writing these two together. Then n is here. And x1 to the power 2n minus 1. Now it has to be a constant length. It will become constant. It will become constant. See, only one term is present here, which is making it a non-constant value. N is constant, a is constant, a to the power 2 minus 2n is constant. Problem is with x1. Why? Till now, the length of subnormal is coming in terms of x1. You will change x1, you will get different length. How you can change x1? Because you can take any point on the curve. It is clearly written any point. So because of x1, it is not becoming constant. But in the question, it is given that the length of subnormal is constant. It is given the question. So it will become constant only when x1 is not there. And what is the way to remove it? Don't say that, sir, we'll put x1 as 0. No. If you want to get rid of x1, you try to do something with 2n minus 1. Make it 0. If you will make it 0, n will become half. That is the answer. And what will happen to this? No matter what is x1, no matter what is x1, power is 0. You put x1 as 2, 3, 4, 5. Ultimately, this part will always give you 1 and constant value. So for n is equal to half, the length of subnormal is a constant value. This is the meaning of the question. Okay, independent of x1 or independent of the coordinates. So this was everything about tangent and normal topic. For next class, you have lot of homework, and apart from that, after discussing, try to solve them. Okay, don't just leave it like that. Try to solve all the questions, and if like time allows, we'll be starting the topic monotonicity. Okay, only two topics are left. So that's it for today. Thank you.
Thank you, sir.